Well, welcome to the West Burns Valley Solar GreenStar Gold Remodel Tour. This course is approved for 1 hour in continuing ed, NARI GBCI, AIBD, certified green and certified green home professional, as well as may be approved for your local state-based or design contractor license. It's also approved for 1 hour in AIA health, welfare, and safety. For this session, I'll be your producer, interview, and camera phone. My name is Brett Little, and I'm the Executive Director here at the GreenHome Institute. We're really excited to be bringing you all behind the scenes through many different homes, renovations, new constructions, multifamily, single family throughout the country. So join us as we continue to go on both our virtual and our Facebook Live tours. And this particular course, we're going to be joining Paul Schulmeyer. Paul guides us through a tour of his 1960s home, which was recently renovated to meet the GreenStar standards, and shows continuous improvement and measurement can still lead to a better home. So we hope you see that whether you're working with clients or you're a do-it-yourself homeowner, it's not just a one-and-done thing. There's actually a lot of opportunities to continue to refine and improve your home, just like they would do in a commercial building setting. So hope you enjoy. Thank you.
Welcome. My name is Paul Schulmeyer. Behind me is my house that I've been working on for about 10 years with my wife, Chris Meyer. This is, we call it affectionately West Burns Valley Solar. I'm a GreenStar rater for the GreenHome Institute. I'm also a Building Performance Institute building analyst, NRPP radon measurement technician. My wife and I do some consulting for the Minnesota Pollution Control Agency RETAP program, and we're going to do a walkthrough of our house, outside and in. So look forward to any questions you might have. I want to start out right here. You're looking street view at the house, and the first thing I want to point out is our native prairie planting right in our boulevard. Many people typically have a lawn mowing boulevard. Here we have a pretty substantial pollinator garden that is very helpful for us, and the produce gardens you can see up in the terraces. When we bought this house in 2008, this was just a hillside sloping up to the very top. So now we have produce gardens, this native prairie planting, and as you see, once we get up to the top, some of our active solar arrays. We're going to walk up the drive, and I'm going to talk about a couple of features that we have that we've built into the surface structure to help absorb some of the rainwater that comes down from the hilltop and from the hard surfaces that we have. So just follow me.
Hey everybody, welcome to the Facebook Live tour here. We are in Winona, Minnesota. So just on the border near, I think, La Crosse, Wisconsin, right?
Yep, we're about 30 miles upriver from La Crosse, Wisconsin, and we're on the south side of Winona, Minnesota, and kind of right on the near the western edge of the Driftless. So maybe your camera can pick it up. We do have a lot of hard surface. This blacktop drive and a concrete parking pad, but off to the right here are actually some terraces that have some river rock in, and actually some rain gardens. And when we actually built the drive, we designed the drive so that the water would slope off to the right, draining into the into the rain garden, so it wouldn't add to the volume of water that's running into the storm drain. In fact, if you come with me and you park your camera right about there, if you look under Brett's Prius, you can kind of tell that the parking pad actually is sloped to create kind of a channel so that the water can run right from the top and drain into this upper rain garden. So really trying to take advantage of directing the hard surface runoff so it comes into the rain gardens and not flowing into the street. So if you come up further, we're going to talk about some more work that we do with the trying to divert the rain. So hopefully most people have rain gutters and downspouts. And one of the things that we've done with this garage addition and the downspouts is we have it draining into a channel here that also pulls that water into the rain garden, this upper rain garden here. So we really do our best to try to keep any of the hard surface water on the property and not running off. Later on, we'll look at one of our storage tanks. We collect about 500 gallons of water on a 1/4 inch of rain. So if you want to come this way and park right about here, we can talk about our active PV systems. We have approximately 5 kilowatts of PV. We have a 3 kilowatt dual axis tracker, and it's just about setting. So the sun's setting in the northwest right now. This is just about, probably in about an hour, this will be resetting and starting to turn back for the morning sunrise. This was installed in 2009, and actually it by itself generates 100% of the electricity that we consume. So right off to the side here next to the drive is a stationary pole mounted 2 kilowatt array we put in 2 years ago, and we installed that system as surplus so that in the event that we would get an EV, then we would have some surplus to charge our EV. And in fact, now we have one. We have a Chevy Volt parked in the garage, and it's not full EV, but maybe sometime in the future we'll go full EV. So if you want to come up a little bit further into the yard, we'll talk a little bit more about the PV, and we'll look at the solar thermal array. So we actually have an extremely large solar thermal array for a typical residential system. You might typically see 2 of these modules. These are 4 foot by 10 foot flat plate collectors. They were made in Minnesota. The goal here is to generate hot water for use within the house. The contractor who installed this, I think, oversold it a little bit as being able to supply a significant portion of our home heating for space heating, and in fact it hasn't done very well. And so what we have is an excessive amount of domestic hot water storage, 240 gallons. It works well for domestic hot water. Typically in about months April, maybe even March through October, we are rarely using our electric hot water heater to actually heat water. And we pay attention to using our hot water. We try to use it when the system is actually charging. So today we did a lot of laundry. There's none left hanging on our solar dryer. But we like to do laundry on sunny days because that way we get our laundry dried by the sun, and we're charging our hot water storage from the sun, so the water that we're using for laundry is used up efficiently. Then if Brett pans down, you can see our terrace produce garden, and we have just about everything most people are growing in Minnesota, Wisconsin, or the Midwest. Onions down below, and watermelons, and zucchini and tomatoes, asparagus off in the background. We have a potato bed, and then coming forward we have green beans, cukes, and we're doing our fall planting. We have cold frames. So in October, these cold frames get covered up, and we'll have lettuce and carrots and kale that will actually be growing all the way into December using the cold frames. And then just behind Brett, we have some University of Minnesota cultivar grapes, Marquette and Swenson Reds. I don't make wine, but they make a really good grape juice. So come with me and we'll look at talk about the envelope a little bit.
I do see, from here I can see the metal roof. Maybe you can tell us a little bit about why you went with that. Is that up there as well?
Well, there are two reasons. One for durability, and then the second reason would be reflectivity. So the metal roof helps reflect some of the sun's heat rather than absorb it. You know, I prefer a lighter colored asphalt shingle if I were going to go with asphalt, but the metal roof has some reflectivity, and so the sun's heat is reflected off and not absorbed so much into our attic spaces, our unconditioned spaces. And then, you know, you can't see it now. It would help if you go to the website, West Burns Valley Solar. You might see some before and after pictures. Before we did this project, the house was actually built in '65, and the whole house has been wrapped with 3 inches of rigid insulation. Large window sections were taken out of the second floor in exchange for smaller units, so we had less sun penetrating from the southwest and the west. Then we actually added some glazing in the front on the second floor. All the glazing on the first and second floor, we're facing almost due south here. So almost all of this glazing is high solar heat gain. Typically you wouldn't see that in construction in Minnesota. We've included it here because we wanted to try to heat or warm up our house passively without using fossil fuels. And so we have casement windows. Casement windows, you know, for standard windows tend to be more efficient than double hung. And those on a day like this are open and helping cool the home. You can kind of see, if you look at the corner where this limestone is, you can kind of see the build out where that 3 inches was added to the envelope. So we actually now have about an R30 to 32 envelope. So coming from the outside working in with the envelope, we have LP Smart Side siding. And then we have an air gap for my nailer, which is a 3/4 inch, and you can't see that nailer. We have the 3 inches of cross-lapped 1.5 inch 150 polyiso, and then Typar, and then the original sheeting, which was 5/8 inch plywood. Then inboard we have fiberglass insulation, which at the time was probably about an R11 in 1965. No poly. There is no poly wrap used in the house because of when this was built. And then we have a 3/8 inch wallboard, and that's got a plaster smear over the top. This was a common construction method for upper end homes in the mid 60s. So really well built, and all those layers add up to about an R31 or so. Well, let's come forward and talk about some of the other features here in the front. So I don't know if you can pick it up from here, Brett. We have a 210-gallon stock tank that collects rainwater from this front half of the roof. The nice thing about our stock tanks is that all the tanks are at the upper end of our terraces. So when we need to water the garden, it's gravity feed. All we really need to do is get the hose in, trigger the pump, and then we can start feeding the terraces with water that's collected in the rain garden. So it actually works pretty well. Then in the back here, we've got a fruit garden with apples, strawberries, and raspberries. And the fence is required around here if you want to keep the deer out. And if you look closely at some of the flower buds, there are bees buzzing everywhere around here, and that's why we have pretty good produce. So Rainwater Collection, again, if you look at the angle here, you can see the build out for the windows. Typically you wouldn't have your windows set back from your outside of the envelope, but it works out well. Have an awning that actually shades during the day this paver patio to help reduce some of the heat that reflects into the house during the day. I wish we had a deeper overhang, but we ran the calculations, and this 20-inch overhang actually, the longest day of the year, June 20th, the sun doesn't actually penetrate at noon into the house. But we do sometimes have difficulty in the shoulder months with some overheating. You can have that with high solar heat gain glass. So, Brett, do you have any questions or any?
Well, I wanted to have you tell us a little bit about your outdoor cooker here and what it's insulated with. I thought was pretty
well.
neat.
So we have an aftermarket. I didn't feel like building one, so we bought this online. It's a pizza oven lined with rock wool, which rock wool, in case your listeners don't know, is a recycled material from the steel manufacturing process. Actually, it's still, we made pizza about an hour and a half ago, and it's still registering about 400 degrees. So actually we wanted to make bread. It's getting really close to the bread baking temperature. So typically this is what somebody would do: fire it up, get it hot, make your pizza, have your dough for bread baking rising while you're eating. Oven cools down to 375, put your bread in, let it set half an hour, 30 minutes, 45 minutes, and bring it in when you're done. So
There you go.
and we're using a lot of ash. So in case you guys don't know, wherever you're listening from, here in Wisconsin and Minnesota, the ash trees are going fast. Probably in Michigan too. And so a lot of friends, they're taking out the ash trees, and most of it, unfortunately, it's a great material for cabinet making and interior finishing, but most of it's going for firewood, and that's what I'm using. So it's too bad. Oh, we got this lawn furniture. So this is a cool thing. So about almost 20 years ago, when my wife and I were living in Rolling Stone at a different home, we wanted to get some lawn furniture that wasn't the cheap plastic stuff like the white ones that are. We wanted robust lawn furniture, and we wanted it made from recycled material. So these chairs and this table actually are made from recycled milk cartons, and we got them in 1999. And they're stainless steel hardware. They look as good as they did 18 years ago. And actually they're pretty nice. And then the patio countertops, I reused some of the limestone that was taken from inside the house, and even the ceramic countertop came from the original entryway that was in the house that I took out and replaced with a vestibule. And we'll talk about that when we go in. So we've reused some of the material that was in the house, different places, and I still got a stack of limestone in the back. We'll see. Pavers from the city of Winona. So back in the day, most of the streets in Winona were paved with these pavers, and they were here. I just repurposed them from a different spot. So let's go in.
All right.
So now we're inside. And do you have enough light?
Could be a little bit more if you have it. Yeah.
Here, this will probably do it. So we just came through the front door. Originally, the front door came right into the great room, and there was no vestibule. So when we did the remodel, this vestibule that's right behind Brett here was actually added as an airlock to help kind of keep the cool air and the warm air from, losing some of its energy. So now when we have people that visit, we have an airlock. So this was added. And other things that we've done, this had an 11.5-foot vaulted cathedral ceiling. Actually, I've lowered it since it's hand-built rafters, 2x6. We really only had an R13 bat in this cathedral ceiling that was roughly 50 years old. So I actually lowered the ceiling with new ceiling joists, almost 2 feet in the center, and then I filled the space with rock wool. So now we have a fairly efficient vaulted ceiling, which vaulted ceilings, for anybody listening, are really the nightmare for energy loss. And then we did put in LED cans. So we actually replaced some lighting that was in here. We have 3 watts in these cans. And then the fans that we have running are actually DC. So they're running at about 10 to 15 watts. So very low wattage for these fans, very efficient fans. So we used to have a closet right here. These posts were required to stay by the engineer because we have a 312 pitch. And the snow load in Minnesota wouldn't allow me to pull these out because this is hand-built rafters, they're not trusses. So we used to have a closet, and then right underneath where Brett's standing, there was a wall. And there was a door on either side. And then we actually had a galley kitchen on the south side to our left. The 1.5-inch gypcrete actually is a mass, not a high mass, it's a low mass, comes up to temperature pretty quickly, and we're able to run the boiler, a high efficiency condensating boiler, for about 2 hours in the morning. We get the room here up from 65 degrees up to about 70, and because of how well the house is insulated, we shut it down, and it'll stay at that temperature for most of the day, especially if the sun's shining. We won't have to run the boiler until the end of the day.
Right.
So I wanted to talk about the windows and the design here. And initially, when we were out front, you may have noticed the hill in the background. And the neat thing about having that hill right in the back of the house is we positioned our first floor windows up near the ceiling in the back of the great room, and you can see here. And originally there was a big set of windows here and a door beneath that mini split. So with the windows up high and the lower windows in the front, what happens is we're able to pull the cold sinking air off the hill. It siphons right through the windows and is drawn through the house at night. When we wake up in the morning, we know that it's going to be a warm day. The house is already naturally cool. We can close it up and actually have cooled the house pretty much for the whole rest of the day. We won't have to run the air conditioner. We can usually do that for a couple of days, unless we're running 3 or 4 days in a row, mid to upper 80s and into the 90s. Then we have a mini split. That's a SEER 30 mini split, Mitsubishi. It runs about 200 watts, 250 watts an hour on Econo. And we have 1,100 square feet here on the first floor, and that's actually enough to take the humidity down and keep it cool enough to be very comfortable here on the first floor. That's a bargain. 250 watts an hour. If you got an air conditioner that can do that, then you're doing really well. And we can actually generate enough surplus to be able to run the air conditioner at that rate.
You run that in the winter at all?
Nope, we don't use it for heat.
Okay.
But because it was the most efficient that we could get, we went with it just to use as for cooling.
Right.
We have a lot of different options for heat. We actually have the original hydronic baseboard. We have the in-floor radiant heat. Those can run selectively off of the condensating boiler. We also have a small EPA rated wood burning insert and 24,000 BTUs, I think that's rated for. That can probably just keep up with warming this lower space. Couple other things that you may see if you look in the corner there, Brett. You can see the blankets, and this is a warm window product, and actually has an R7, R5.
It would bring single pane to an R7.
Yeah, and so it's a blanket. We've woven a magnetic strip into the edges. This is the warm window away. Instead of having the magnetic strip face mounted. Actually, I've daddoed it into the edging of the casement. So on the lower level, if you look at the side of that one window up above there, you can kind of see the magnet on the edge next to the left of that mini split. Yep, a black strip there. And so when the blankets come down, they actually strip around the edge instead of having that kind of clunky looking magnetic strip on the face. So it's just, it's carpentry. If you have a carpenter that you know, that's one way of doing it. So it helps add some R. Remember, windows are the weakest link in the envelope. And so we didn't go all out for a European window with triple pane, R7. We have an R3 glass, high solar heat gain, so this is the weak link. I didn't even bring out one of the, Chris is actually going to bring outside one of the insulated panels. She'll set it outside. Maybe when we're done inside, we'll have a look at that.
Okay.
We actually built some insulated panels because that's the real deal, is if you insulate the glass from the outside, you keep the temperature of the glass inboard at near the temperature of the inside of the house, then you get no condensation. And that's the best way to do it. Exterior shutters. So don't forget that. I mean, exterior shutters. So we're going to look at some of the appliances we have. I'm going to turn a light on here for us. So we have an induction range. We don't have a cooking hood. So we pretty much eat low on the food order, so we don't eat a lot of meat. And so if you're not doing a lot of protein cooking on your stove, you don't have to have a lot of ventilation. Brings water temperature for coffee up to temperature really fast. The nice thing about induction is there's no exterior heat, so there's none of this heat loss. And I know a lot of people like cooking with natural gas, and I used to as well. But besides the heat that's being thrown off to the sides, you're also throwing a lot of moisture into the air. And that moisture in a tight house has to be removed mechanically. So again, we don't have a vent. We do have windows here, strategically located in case we're doing a lot of cooking. So very efficient. It is electric, but again, remember, we're generating excess energy from our PV array. And we have a Sunfrost, a refrigerator. You can see from the walls how thick, well insulated it is. Sunfrost doesn't make refrigerators anymore, and that's too bad because I think they're very simple and very efficient. The compressors are located at the top. You can't see them, they're hidden behind this panel. They're located at the top, and so that heat that they are dissipating isn't rising through the cabinet, causing your refrigerator to work harder. So if Sunfrost isn't making it, somebody should be making a refrigerator with the compressors on top. And then the freezer does not defrost. So remember, a defrost mechanism is like an air conditioner. It's taking moisture out of the freezing compartment, and then meaning it's removing the frost. Because there's no defrost mechanism, we have to defrost it manually, but it's about 30% of the energy use because that has to cycle in order to take that moisture out of the cabinet. So this is one of the reasons, besides the thickness of the cabinet and the compressors being up on top, it does not defrost. Also, that moisture stays in the main cabinet and keeps our produce fresher.
Mm-hmm.
So one of the benefits of having a non-defrosting cabinet.
So what's the like the process of you going through to do that? I mean, what happens with what's in your freezer while you're doing that?
If you're my age, back in the day, in the 60s, many refrigerators didn't have freezers. Refrigerator freezers didn't have defrost mechanisms. So you pull out your frozen items, you put them in a cooler, you leave this open, you let the ice thaw out until it drops out, you put it in the sink, melts, and you clean it out, everything goes back in. So we have to work a little for this, but this is, at the time, we bought this in '09, was about the most efficient 16 cubic foot refrigerator you could get. They may have some now that are as efficient as this, but it's a very nice unit. So one of the things that we do is we manage electrical use with power strips and outlets. So in order to have 5 kilowatts be excess surplus for a 3,000 square foot home, you have to do something inside to reduce your usage. So that's this refrigerator, that's the mini split, that's this induction oven, but it's also all the other things that we typically aren't running or aren't running when we're not using them. An example would be a toaster. So a toaster is drawing a few watts constantly. So when you put the toast down, it comes on faster. Well, we actually have a little personal power strip right back here that actually cuts the power to the toaster. And when that's flipped on, it allows the toaster to be pre-charged and ready to fire up. At night when we go to bed or when we're not using it, that's turned off. Now, a lot of people are thinking, well, okay, what's a couple of watts? You start adding all of these appliances up, and now a typical home could be using 50, 80, 100 watts a night, every night, without actually anybody doing anything. Same thing with our microwave. Microwave is typically drawing about 11 watts because it also has an element that's going to be ready on besides the clock. So we again have a little power strip. Our microwave is only on when we're going to use it. So same thing with our entertainment center. We have a flat screen, we have a laptop, a modem, a stereo, a printer, all plugged into one power strip. At night, one button, they're all off, and we have no phantoms. So we do that in other rooms, other parts of the home.
I know with modems, sometimes they can be touchy if you power them down, try to power them back up.
Yep.
You haven't had any issues with that?
No, because we do have one modem we leave on upstairs all night long.
Oh, okay.
So we have 2 wireless.
Oh, okay.
And so one is always on.
Okay.
And one we turn off every evening. The other thing we did show, we could, but we'd have to power up the computer. We also have an energy monitor, so we actually know how much we're producing, how much we're using, and that's information that we use. If we see that we've been drawing high, we try to figure out where is that load coming from. Because once you get started on this path, you actually start, it becomes an addiction. You want to improve and become better at your energy efficiency. And that's part of how it all works, is becoming efficient.
Yeah, maybe you can share some screenshots of that with folks watching this later.
Yeah, and I might be able to fire it up, and then we can actually have a look at it real time. Because we're still probably generating a few hundred watts. Because it's 7:30, we have enough light, we're probably generating 500, 700 watts right now.
And what brand, I have to ask, is that, you know, I go around unplugging everything. I'm sure a lot of people listening do, but that makes it way easier. You don't have to find, scramble, look for the plug.
I can't even remember. We bought these, I don't know. I think it says, does it say GE?
Yeah, sure
It
enough.
does. It's a GE.
Huh.
So there you go.
That's one thing that I'm surprised I'm just seeing now.
We actually had to buy them online.
Yeah.
You couldn't get them at Menards
Right.
or Fleet Farm in
Yep.
our neighborhood. In the back corner here is our laundry room, and of course front load. So front load means we have high spin dry. Front load means lower water usage. Lower water usage and high spin dry means the clothes go into the dryer if we use it. They go into the dryer.
Right.
Okay? And then the dryer works less if we're not using the solar dryer outside. So again, front load washing machine, low load. Although they are making some pretty efficient top loads now. Again, Energy Star.
Yep.
That's really the way to go. I can't emphasize enough about doing Energy Star. I want to show you the, actually, let me do this. Okay, so water usage, yep, we're in the bathroom. But it starts with low flow flushing, low flow water and shower heads, so that when you're using water, you're using significantly less. So low flow is about 1.5 gallons versus standard, which will be 2.5. If you have one of those big 10, 12-inch rain making machines, they're dropping like 5 gallons a minute. I mean, a lot of water. So low flow, less water, less hot water, you still get it clean. And that's an important thing to do. Other things that I've done, all the woodwork on the first floor is actually, I milled it myself. It was harvested here in actually across the river in southwestern Wisconsin. A friend had it drying in his garage, and I repurposed it, milled it with my planer. So all the woodwork here in the first floor it's red oak, and it's from the local area here.
That's the cabinetry too?
Cabinetry, the oak was harvested in Wisconsin, but those are custom made by a local cabinet maker. Yep. Butcher block was made out of recycled birch and what was the other one? That actually I pulled off of the casement before. So, yep, we do can. So we're going to go into the basement, and the reason why we're going down there is we're going to look at the mechanicals for the solar thermal array. And that's this way. So yes, I have a bike shop. We try to get around on bikes, and I've been a bike mechanic from the earliest days, and so one of the things that my wife helped me do in the early days is acquire all the tools needed to do all the work on our bikes. So here is the kind of the lower end of the solar thermal array, and we have a 15-gallon drain back tank, and right now it's not running because it's 7:30 in the evening. The Eagle 2, this is the controlling unit. The copper piping, so the glycol is, when it's warm enough, the solar thermal array has a sensor on it. when that sensor gets to 8 degrees warmer than our collection, our storage, the pump comes on, starts drawing antifreeze, glycol, and it's animal safe glycol. It pulls it through the collectors and it starts running it through the collectors. It returns, comes down through this heat exchanger, which is basically a stack of stainless steel. On one side the glycol runs through, and that hot glycol then heats up that stack of stainless steel, and the heat is exchanged, that's why it's called an exchanger, to the water side. And then the water side pump starts, and the water starts pumping through the exchanger, picking up the heat as it's running through, and it sends it back to the storage tank. Once the storage tank gets to a maximum of 168 or 170 degrees, the system will shut down, and the glycol will drain back into the drain back tank. Drain back because we're in Minnesota and we don't want the material sitting out there in the collectors cooling. Or heaven forbid, if it was water, which sometimes you have a water system, you still want it to drain back so that you can keep it from freezing because water will expand. The system works pretty much effortlessly without a lot of work. And then we have the storage. We can go have a look at the storage if you want. And that's in the back. And this is going to be low light, so I don't know. I should have probably turned this on earlier. So back here are 220-gallon storage tanks, and we had a partly cloudy day, and the two of us have both taken showers. We did about 3 loads of laundry and some dishes, and our storage is at 140 degrees. You see up here. So if we wanted to, this could be used for space heating, and this is too warm for space heating. If it was going to be used for space heating, it actually would run through another exchanger, so the water could be tempered, that runs through the floor, and that manifold is up here. So it would run through here, the heat would exchange, and then the floor water would run back through the exchanger, heating our floor. These days we don't use it because it actually doesn't work that well, because it needs a minimum of 125 degrees actually to get enough energy to put into the floor. So instead we use the triangle tube, which is a multi-purpose high efficiency condensating boiler. This boiler can run our hydronic baseboard, or it can run the in-floor heat. And in fact, if we wanted to, we could hook up a domestic hot water heater to it. It's a very sophisticated boiler, 95 to 97% efficient. So, and right here, built-in cold storage. So we're growing potatoes and onions and squash, and we actually have an air dump from outside. It serves 2 purposes, brings cold air into this closet that's insulated, keeps our produce cool, and then actually also brings in fresh makeup air for the house, because we're a little short on fresh air because of how tight the house is. I don't know, this isn't a good place to see, but the rim joists have been spray foamed, and then the interior of the basement has a 1.5-inch rigid insulation wrap. And then the wall is extended in from that. So we've lost some square footage, but we did everything we could to keep this space conditioned, even though it's not officially conditioned. So
What's tightness? What's your air exchange rate? Do you remember off the top of
We
your head?
ran a blower door on the house and it blew a 1.7. So 1.7 air changes per hour.
Okay.
Which is in Minnesota. Minnesota requirement is a minimum of 3 air changes per hour for new construction. If you go below 3 air changes per hour, then you need to add fresh air in order to make up for the lack of fresh air in the home. That's our air dump. Of course, we have the house open quite a bit. We have 2 issues because of how tight the house is. And the first issue is radon. So you may or may not have seen the radon fan on the outside, but we've had to mitigate the home for radon.
This radon zone 1 here, or 3, I forget which is the worst. But
good question. So
sure we have it in the
we
docs.
have higher. Our typical home in this part in the drift list is about 55% of the homes will be elevated.
So they usually go by county, but then there's always local data. So you're saying you're kind of
Right. So
particular
in Winona County, 52%
Uh-huh.
are elevated. Across the river, we have slightly higher.
Yeah.
So we have a mitigation system installed
Yeah.
because if you have a tight home, you have to test for radon. I can't. Yes, I'm a certified testing measurement technician, and it's not a sales pitch. We had high levels here, and then we also have moisture. So we're considering mechanical ventilation. We do have spot ventilation. So we have Panasonic, low wattage, spot ventilated
Whisper Green?
Whisper Greens in both the downstairs and our upstairs.
Do you have them run intermittently at all? Or?
They run, they're set on a humidistat.
Oh, so just for when there's humidity.
Yep.
Yeah.
So they do the trick.
Yeah.
But
What in the wintertime, do you have them come on a little bit more? Or,
a little bit more.
your windows
And we
open?
try to manage how it's going in the house. But we may be still be looking at mechanical ventilation. You do a job like this, and you have to consider the impacts on indoor air. I can't emphasize that enough. I mean, I'd be reluctant if I didn't. We've been going through the house, we replaced incandescents when we first moved in with CFLs. We got a big bag of them here and some old T5 or T8s, 4-footers, and I have some older fluorescent units that have been exchanged out in our workspace upstairs for LED units. They're really reasonable these days, and so we're actually using less energy and getting better light. So why not? Why aren't these in the garbage? Because they're compact fluorescents and they have mercury in them and they need to be recycled properly. So there's probably about 50 bulbs in there, and so don't throw your CFLs in the garbage. So I wanted to go outside. Are there any questions?
No, right now.
None coming up. So I wanted to go outside. I think Chris pulled out one of the insulated panels for the front windows. And then upstairs is kind of a repeat of the first level. We have the blankets for the windows. And again, power strips, doing what we can. And we did add a 9-inch fiberglass blanket on top of the 9-inch we had to try to get us up in the attic to the proper R value. So in our climate here, I'm not sure about where you are in Lansing, but where R49 is code in Minnesota. So I'm going to get some lights as we go up.
Okay.
So. We'll go back out the front. Yep. she put a panel out there, so thank you. So we're going to go back outside and look at one of the things we didn't have ready. So actually, a couple of winters ago, we built these insulated panels that actually go into these window spaces in the wintertime. We have to take them out. We don't have to. On a sunny day in the winter, we take them out.
Right.
If the sun's not shining in the winter, we actually leave them in. Remember, this is your windows are part of your envelope. They're the weakest part of the envelope. We add an R10 to that window. We've actually made that window more efficient than 70% of the homes in Winona. Mm-hmm. Because most of the homes in Winona are 80 years old or older. And more than half of those don't have any insulation in the walls. So we have a shutter like this, a panel for each of these 4 windows. We're actually considering an automated unit for the windows up above, and I'm still working on that. So if any of your listeners want to help me engineer that, I hear that that there are some pretty neat low wattage motors made in Germany that actually are designed specifically for that purpose. Mm-hmm. So that's about it for the tour, unless you have some questions.
Yeah, I was going to say, let's talk a little bit about some energy data. I know, I think just for the sake of time, we'll maybe get some screenshots and show folks later on who watch this later. But as far as just, well, one of the questions I had about the window here is, have you maybe spent 1 year actually using it and then a year not, and trying to compare what the savings were? Have you any idea on that?
Well, so we've had you mean the insulated panel? Yeah, so 2 winters. So 2 things that we've noticed. A lot less moisture collecting on the inside of our windows because of this whole warm, cold issue. And we have wooden clad interior windows, so that can have a big impact. Since I lowered the cathedral ceiling and added the rock wool in the cathedral ceiling and the insulated panels, we're down about 150 therms from the previous winter. It's difficult to actually manage that because we've had 2 warmer winters. 13, 14 was kind of a cold winter. But I think it's safe to say somewhere around 100 therm impact.
Okay.
Because of the lack of heat loss at night, and that with the lowered cathedral ceiling. So, yep, they're manual, but it's Minnesota.
Right.
So.
Yep. And then as far as total energy use, taking gas, electric together.
Yeah.
I mean, you had mentioned that you're pretty much offsetting most of your electricity with your solar, if not all of it. And then of course you got the thermal panels. So what, just percentage-wise on average, are you offsetting, totally?
So we use about consumption about 3,500 kilowatts a year. That's consumption. We generate about 5,600.
Okay.
Maybe less. Seems like, well, it should be, we only got 5 kilowatts. How could you generate 5,600? Well, we have a dual axis tracker, which actually does really well.
Right.
But somewhere between 5,000 and 5,500 is a fair guess of what we generate. So 150% of our consumption. Okay, that's on electric side. Right. So then we use, in 2016, we used roughly 300 therms. of natural gas. One therm is equivalent to about 28 kilowatts. I'm just rounding.
Yep.
So you can do the math. Let's just say 30 kilowatts and 300 therms. That's about 9,000 kilowatts. Okay. So you'd need to generate 9,000 kilowatts to make up for those therms. Plus the kilowatts that we're consuming. So you add all of that up, I think we're around 13,000, 14,000 kilowatts.
Yeah.
Very rough numbers.
If I remember the recent EIA data, just the average, I know the average Midwest home used around 36,000 kilowatt hours. So you're a third of that.
Less than half of that.
Yeah.
Yep, we're less than half of that, and this is a 3,000 square foot home.
Right. And then you knock more than a third from the solar, right? So,
yep.
Yeah.
And we're generating more than a third of that from solar, and we do pretty good passively.
Yeah.
So,
you just fortunately can't sell back your hot water to anybody.
No,
right?
actually we were considering some uninsulated storage on the living floor, and actually a finished storage, hot water storage cabinet that would self-radiate, but it's just way too expensive because the cabinet has to be designed, the stainless steel tank has to be designed, and then we have some plumbing. We're going to split this into two.
Okay.
That's actually, I would, up front, I'd say give that a thought if somebody's considering solar thermal. Put the storage in your living space and don't insulate it.
So I kind of like the idea that, sometimes people do a green project and this is it, we're done. You kind of have this work in progress going on where you can always continue to improve.
Yep.
So that's a really cool thing to think about and consider, and that's one of the ways we've set up GreenStar, for folks who might get to a certain level but then be able to continuously improve. Obviously you're at gold right now, but that doesn't mean even LEED Platinum homes have more that can be done to them. So have you shared everything that you, from a sustainability standpoint, you think, or is there anything else you're working on?
So we actually are. So we actually just got an estimate on splitting the solar thermal system and doing so, and that wasn't feasible. Actually, the return on some of the work that we've done is pretty far out.
Yeah.
Our solar PV went in 2009 at $8.10 a watt.
Yeah.
Okay, so PV's at $4 a watt now. So, but I think we're seriously going to go with heat source, heat pump, electric hot water heater, because we have all those mechanicals in the basement. The basement is the warmest place in the house year round, and so we have all that extra heat in there that we're gonna pull and siphon off to preheat even more of our hot water. So we're preheated. When it's cloudy, we have to use the electric elements in our original electric hot water heater, but we're going to change that out for air source heat pump, draw some of that heat from the basement, and use it to preheat our domestic hot water. So actually, we're going to probably do that this summer. And then we have some pretty good 366 low E windows up in our bedrooms. And I think we're going to start replacing some of those with European triple glaze. Yep. And probably get rid of the wood cladding on the interior. Go with the fiberglass if we can.
Now, most folks are doing, unless they own a farm or a lot of land, are putting solar on their roof. What's the number one reason you didn't do that? And then number two, are you considering adding any more solar up there?
So if you can step back and have a look at our house, we have the second story actually blocking the roof of our great room from the western southwestern sky, and blocking our garage roof from our eastern southeastern sky. So we actually have a significant loss for our solar gain as you go through the course of the day if we put panels on those roofs. Also, they're 312 pitches, which in winter would be really great. We'll get high gain, but they also will collect snow, and they're difficult to keep clear. So I know a lot of contractors will say they'll melt off, and they do. But at a 312 pitch, if we have a winter like 2010, 2011, where we had over 70 inches of snow, and at sometimes we had 18 to 20 inches of snow on the ground, many people I knew who had roof-mounted systems did produce for 2 or 3 weeks. So we have the dual-axis tracker and manually adjusted stationary that I can set for 60 degrees, 45 degrees in the winter, 50 degrees, whatever I need to. The snow will melt and roll right off, or I have a telescoping pole, I can brush them off. So we're generating electricity the very next day that the sun comes out. So it costs 20%, 25% more because you have to put the footing in. So it's more expensive, but over the life, we're actually generating a lot more electricity. And who's actually out there has 3,000 square foot home and is generating surplus just on 3,000 watts. And we were doing that. And so, and then we have the 2 kilowatt just for surplus for charging an EV.
Great. Well, hey, really appreciate you having us come into your house. Where can people get more information if they want to work with you to be a GreenStar or home energy or home inspections in the what areas do you serve within Minnesota?
Southeast Minnesota. So I'm happy to do GreenStar rating for GreenHome Institute. Actually, I've been doing some work in the Twin City area. I do home inspections here in the Winona area, not in Wisconsin, so this side of the Mississippi. Radon measurement certified nationally, and energy audits. I'm an independent, so you get a lot of personal information, personal advice, care, and recommendations from my experience. But you don't get contract, rebate information, or light bulbs or low flow shower heads, because I work independently. If you want to see what our home looked like before we bought it, you can go to our website, West Burns Valley Solar. My business has a website called Efficiency Detectives, and you can go there, like us on Facebook, and you can reach me at pwsolar23 at msn.com, or that's good enough.
Okay. All right. Well, thank you.
Thanks, Brett. Appreciate you coming.
All right. Well, that is the end. Thank you again to all of you for watching, all of our members, our sponsors, our board of directors. Thanks to our volunteers. Thanks to GeoComfort, Build Equinox with the smart ventilation system, Sun Intuitive self-tinting glass, Niagara Conservation, Panasonic Ventilation, and Certainteed Air Renew formaldehyde eating drywall. Couldn't do it without them. We couldn't do it without you. To pick up your continuing ed for this course, make sure to complete the 10-question quiz and then get an 80% passing rate. Please join us next time. Thank you.